So before starting, I want to ask the question, does anyone know about an oscilloscope? What is an oscilloscope? Have you seen this in, let's say, your lab or any YouTube video or any online tutorial which you basically went on towards? What is an oscilloscope? Just a brief, just one line answer. Maybe a guess. What is an oscilloscope? Yes, anyone. You're not getting marked for correctness. I just want to test your concepts right now. कितने अच्छे हैं आप? Okay, ठीक है. Okay, वरदान ने देखा हुआ है. So, what can you, let's say, measure from this, from the cathode ray oscilloscope? Chale, I believe that at your level, you might have not used this. You might have seen this only. So it is widely used in industry or in your university level. You will use this rigorously. Okay. So let's start this first of all. Let me just start to briefly describe what is an oscilloscope, right? So it basically captures electrical waveforms, right? So it works on the principle of electron gun, right? You have learned this in your chemistry or in physics, in your chemistry lectures. Okay, what is an electron gun, right? Basically, it emits electrons over here, right? So oscilloscope basically does what? It emits. It basically emits a ray of electrons, right? So it has a screen. So when the electron hits a screen, so electrons produces a bright spot upon hitting the screen, hitting the screen, right? So if I can explain the structure in a brief way, that is going to be as follows. So you have an electron gun, right, which emit basically beta particles, which are electrons, right? It emits electrons, right? And you have a screen here, right? When the electron hits the screen, basically gives you a bright spot, right? So if you basically, it has two settings, it has two motions, it has x-axis and it has y motion, right? So this is basically used to show time, right? It shows time in milliseconds, and this y value basically shows you the voltage level in volts, right? So you can basically adjust these settings to basically display different types of waveforms. You can display DC waveforms, right? Which is time. This is V. You can also display AC waveform, right? Depending upon your input. And you can also display just a spot here, okay, which is basically depending upon your different type of settings. We will explore both of the all of those scenarios in your lecture. So this is just a displaying uh we can say instrument which is just used to capture the nature of the input waveform which you're trying to display over here, right? So it is the complete name of the oscilloscope is basically cathode ray oscilloscope because it has a cathode gun which basically emits electrons, and oscilloscope is basically just displaying the waveform captured over here, right? So you can also see the circuit symbol over here. This is a circuit symbol of an oscilloscope, and this is the actual oscilloscope which is found in labs. This is an older version. We have advanced version of oscilloscopes also. And you can see over here we have a wave getting displayed over here, right? So this is displaying an AC waveform here, right? That is alternating because you can see it's a sine wave. It's basically repeating over here. It's basically getting displayed over here. And you have an analog screen over here. So these basically green lines which are shown over here are basically electrons hitting, right? So these are electrons hitting over here, right? So these are electrons which basically glows when it hits on the screen and gets displayed on your oscilloscope screen here, right? So this is how the cathode ray oscilloscope works over here, right? Now we have some settings over here. As I told you guys before, okay, we have two axes in this oscilloscope screen. We have the x-axis which shows basically time in milliseconds, right? And we have the a voltage division screen, that is the y-axis, which shows the voltage magnitude, right? कि कितना magnitude है voltage waveform का, that is displayed on your y-axis over here, right? So we're gonna learn about some settings here, which is going to be we have two controls over here, that is the time base and the y gain here, right? So this basically control mechanism is called time base settings, right? So we control these two settings in your oscilloscope probes. You can see you have two knobs here. So one can be used to display control the time settings, and one can be used to control the y gain here, that is what is the voltage magnitude that you want to display on your screen, right? So this is the y gain settings here, which you can tune using your knob here, which is present on the hardware of this particular oscilloscope here, right? So let's see what is how is it constructed here. So the vertical axis on an oscilloscope provides the measurement of the potential difference, that is the voltage that it is displaying over here, and the horizontal axis shows the time, right? Okay, how much time it takes to complete one cycle, right? So from that we can find the time period and the frequency, right? The signal to be displayed or measured is connected to the Y input terminal of the oscilloscope. The Y gain controls or amplifies the input PD to make large enough to appear on a suitable size of the screen. So the Y gain is basically voltage per division. Okay, and it basically allows you to manufacture the size of the input which you want to measure over here, right? And time-based settings controls how fast the bright spot basically move from left to right, right? Because you have a single gun which is emitting just electrons, a beam of electron, right? So this screen is basically causing the motion, right? Let's say this electron hit in this particular direction in this way. So this it forms a sine wave, right? So this screen is basically the movement on this direction is called the time-based setting. So the smaller it is, the faster it is moving to capture the actual waveform here, right? So this is the time-based setting which is they are referring to over here, right? So the distance moved by the spot is directly proportional to the time, and so the horizontal axis becomes the time axis, right? So they are saying okay, why is it basically why the axis is called the time axis over here? Because you are basically plotting electrons per millisecond, right? How many electrons are hitting on the screen in a time of 1 millisecond over here? That is controlled by the time-based settings here, right? So it is by millisecond per division or millisecond per division. Okay. So it basically allows you to plot different potential differences in a amount of certain time, and you can display a waveform here. Okay. So let me summarize the results. You have this basically screen, right? And you have this waveform. Let's say it's a bad waveform. Let me fix the. Okay, this is time, right, in milliseconds, and this is voltage in volts, right? Let's say the आपको जो input था that was only 5 millivolt, right, and negative 5 millivolt, right? When you display it on the oscilloscope screen, it might appear like this, very small, right? So you can control the Y settings, right? You can control the Y gain. Let's say you make it to 1 millivolt per division, right? So this would amplify the signal to this, right? So this is one box. This is second box over here, right? So it will capture this waveform in two boxes over here. So it will become more visible to you, okay, compared to just seeing this waveform physically from your naked eye, right? So this is the wire gate control that you can set over here, right? What is the time-based settings? Let's say this waveform takes 1 millisecond to complete one cycle, right? And this is 2 millisecond. This is the next cycle over here. Let's say if you actually display this on the oscilloscope without any settings, okay? So you got this waveform. Let's say this waveform, right? Let's say you want to see more number of cycles, right? You want to see more number of cycles, so you can reduce the time-based settings to basically see more number of cycles, right? Let's say यहाँ तक वो basically it was only two boxes here, right? It was 1 millisecond here. It was zero point 0.5 here. Let me show you here. It was 0.5 millisecond here. So 1 millisecond here. Okay, time is in millisecond. And these are only two boxes to capture कर रहे थे, right? So if you want to plot, let's say if you decrease the time second settings to let's say, let me make it to let's say 0.1 millisecond, right? So now it will basically try to capture more waveforms. right? Let me just let's say increase it to, let's say 10 millisecond, right? 0.1 millisecond. Let me just do this. Okay. If I increase the ambient settings, so it will basically make it more shorter, more zoomed in. If I increase it to 10 millisecond, or let's say 3 millisecond, okay. Now my time based settings is basically 3 millisecond per division, right? So that means that my one box, that is my one box, it will basically capture, it will travel 3 millisecond, right? Okay. So now in this particular setting, my two box on the oscilloscope screen, first will basically hit 3 millisecond, okay, and the second one will hit 6 millisecond over here. So I would capture basically 6 waveforms here. Let me fix it over here. 1.5 would be here. Okay, ठीक है. Not so. Let me make it more smaller. Zoom in. ठीक है. So this is one cycle. One. This is another one. This is another one, right? So we have three cycles here, and then we have three cycles here, right? So it makes sense, right? इसका time period क्या था हमारे पास? If you see over here, the time period for one complete cycle was 1 millisecond, right? तो मैंने क्या करा? मैंने basically इसकी time based settings मैंने बढ़ा दी, right? मैंने time based setting जो इसकी X space की settings हैं. Now my one box will basically display, my one box will basically display a time division of 3 millisecond, right? So since it basically takes 1 millisecond to complete one waveform. So if I have 6 millisecond time duration, it will display 6 cycles here, right? So I can now observe more number of cycles here to basically analyze, or let's say do some analysis over here, right? So if this thing makes sense, give me a thumbs up. These are the set questions which you get asked in your MCQs and your theory. Okay, makes sense to Varda. What about Hamza, Mashal, and Umama? Okay, makes sense to Mashal. Okay, so just understand this. How do you control this, right? This is a summary over here of what we have discussed. So the wire gain controls the magnitude, the amplification that you want to apply to the input, such that it becomes visible. Okay, like this. Okay. And what is the time-based settings? It controls the time interval that it basically displays on the oscilloscope, right? How many waveforms you want, how many cycles you want to display on the screen, that is decided by the time-based settings over here, right? Okay. So you are basically zooming in, right? यहाँ पे you're basically, let's say if you want to go from here till here, you're zooming out, right? You're just zooming out, right? We're capturing more waveforms just to see how is the trend of the signal over here, right? So that is how you can control these two knobs to basically get a different required visible structure of your waveform to have a good analysis over here, right? So these are two main settings which you control in an oscilloscope, right? Okay, so now what type of sort of signals which you can display on your oscilloscope? Okay, so that is what we're going to discuss over here, right? So this is the center of your oscilloscope. 1, 2, 3, 4. We have 1, 1, 2, 3, 4, 5, 6, 7. So 3.5. 1, 2, 3, 4, 5, 6. This is center of your oscilloscope. This is the center of your oscilloscope, right? This is your time axis over here, and this is a milliseconds, and this is your voltage in volts, right? And this is just giving you a horizontal line which is centered at 0, which is saying that you don't have any input, right? It's just 0 volts. So your basically waveform which you have the input which is you're sending over here to oscilloscope, it's just basically a 0 voltage value, right? So from all the time, okay, it basically is 0 here, right? uh Now you basically want to do what? You basically, let's say आपके पास circuit है, you have an oscilloscope, You have an oscilloscope, CRO. Let me label it out. Now you have a CRO, right? And you have the positive leg of the CRO and the negative leg of the CRO. I connect it with a, let's say, a DC battery of, let's say, 1 to 4 volts, right? So now on the same axis here, this is the time in millisecond, and this is voltage, okay, in volts. So let's say your settings for the Y is basically it's 2 volt per division, right? That means my single block shows a voltage of 2, right? This is 2, 4, 6, right? So the magnitude of my voltage battery should be 4 volts. It is showing an exact horizontal line of 4 volts here. It's a DC voltage, it's going to be constant throughout the time, right? So you get a constant horizontal line over here, right? So that's how it measures the voltage here. Now let's say you have an AC signal here, right? आपने AC supply को लगाया with CRO, right? This is the positive leg of the CRO, and this is the negative leg of the CRO, and you want to basically measure it out, right? And after connecting it with the CRO, you get this particular waveform, right? Let me again fix my settings. This is the center of your screen, right? This is voltage in volts, and this is the center of your time. This is time in millisecond, right? Millisecond. So now you can see that you have a cycle which is repeating, right? So you have a sine wave, which is basically starting from here, starts from here, goes here. Okay, you have a sine wave here, right? And let's say you were giving input as a 2 volt input, right? Let's say a 4 volt AC input, right? So that is 4 volt per division. Okay, आपकी setting same है. That is the y-axis is showing 2 volt in one box, right? So this is 2 volt here, this is 4 volt here, this is 6 volt here, this is -2, this is -4 here, right? Since AC is a mirror image, okay, it is uniform. This is +4 here and this is -4 here. It is oscillating between +4 and -4. So you can also find the time period it takes. Okay, let's say my time base setting was 1 millisecond per division, right? It means that मेरा one box is showing a time difference of 1 millisecond. Okay, so I can also see that my one waveform complete from here till here. This is one cycle, and how many boxes does it captures? Capture it travels for 2 boxes, right? So my one cycle is getting completed in 2 boxes, right? 2 divisions. So I can find the time period also. Okay, that is simply 2 times 1 millisecond. Because what is my setting of my oscilloscope? That is every block is showing a difference of 1 millisecond, right? So if I want to travel from here till here, so it basically captures a distance of 2 millisecond in time. Okay. So my time period for the wave to complete one cycle is 2 millisecond, right? So if it makes sense, give me a thumbs up. Just to see, just we just saw okay, how what type of signals can we display and what are the settings which you can see over here. How can you basically measure the voltage magnitudes and so on and so forth, right? So it makes sense to Hamza, Mama. What about Mashal and Varda? Okay, makes sense to Mashal. What about Varda? I have a chat here. Okay. Current voltage. Okay, I guess you are participating. Okay. Okay, I hope it makes sense. Okay, so let's this is a summary over here which we discussed. So let's read the summary quickly. So they're saying that with time base switched on, figure 4.6.2 shows a display on oscilloscope screen with 3 different inputs here, right? So in figure 4.62a, that is this one, it is basically showing that the Y input is 0. Okay, that is we have input of voltage 0, right? You have no voltage input over here, so it's going to be a horizontal line, basically balanced at 0 volts here, right? Then you have 4.62b, that is it is displaying a constant DC voltage, right? You can see it over here, right? And in your third figure, you have basically input that is an AC signal that is basically fluctuating or moving around +4 and -4 here, right? Okay. Now, what if we basically let's say close the time based settings? That is कि हमारे पास ये let me just take you here. Let me copy this. To a different empty screen. Let's say you have basically this CRO, right? Let's say you are controlling your voltage Y base setting here, your Y gain from this knob, right? And you're controlling your time based settings from this knob here, right? Let's say if you don't have this, okay, if you turn this off, okay, if you turn off the X settings, let's say we only have Y axis, right? We only have Y axis over here. We don't have X axis, right? We have only Y axis over here, right? So what would happen to the waveforms which you want to display, right? So again, we have three scenarios here. That is, आपके पास CRO लगा हुआ है with a battery, let's say with a battery that is almost discharged, इसका voltage हमारे पास zero हो चुका है, right? And then you have second scenario जिसमें हमारे पास battery है which is connected with the CRO again. This is the positive leg of the CRO, this is the negative leg of the CRO, and this is the negative of the CRO, right? This is 4-volt battery here, and this is an AC signal, right? Which is again connected to a CRO, cathode ray oscilloscope, right? And it's a 4-volt peak to peak signal, right? Which you want to display. 4, -4. This is time, this is voltage, right? So you don't have now time-based setting, right? That is, the screen is not moving in left and right directions. It's not capturing all the electrons here, right? So what would happen? You have an electron gun, right? We have an electron gun, right? Which is hitting electrons, right? On the screen. So you can, your screen is only capturing basically the motion in a y-axis, right? So it is not moving left and right, right? It's not moving in left and right direction. So if you want to just display 0 volts, it's going to be, the electron are going to hit only in the same spot forever, right? So you're going to have a only single dot over here, which is at the center of your axis, right? So if I make the set axis again, this is x-axis, okay, and this is the y-axis over here, right? So you don't have y-axis right now. So all the electrons are basically hitting a single point, and it displays all the basic bright spot at the center point here, right? Similarly, if I draw this axis over here, this is the voltage axis over here, the voltage axis here, okay, and voltage is here. So you can see this is again, this was the center point here, and this is again, we have settings of Y gain as 2 volt per division, right? That is, one box is saying 2 volt and this is 4 volt. So all the electrons are hitting again a same point. That is a same spot here. The screen is not moving in this direction, right? It is not capturing a horizontal line like this, which is going to be basically a DC volt here, because this is turned off, right? The screen is not more capturing the X axis motion here, right? So you again receive a dot here. Okay. What about this? The case C, you again have the axis over here, right? This is the voltage, okay, and this is the time in millisecond. This is turned off, okay. So your AC is basically alternating, right? So your electrons basically first of all goes in for a positive direction and a negative direction here, right? But there is no motion in this particular direction, x-axis. So that is why all the electrons are basically hitting, like just moving up and down, right? It is not moving in this direction, so it's not capturing the sine wave here completely. So this is the thing which you will basically encounter if you turn off your time-based settings here, right? So that is the importance of the control knob of time-based. Okay, so if you don't have the screen capturing the time in a certain amount of time, it does not capture the actual scenario, the actual nature of the input waveform here, right? So this is a summary over here what we have discussed. So let's summarize this. So when the time-based setting is switched off, the trace is concentrated to a spot that does not move from left to right, right? Your left to right motion is now off. So figure 4.6.3 shows three inputs, which we just saw here. You have 0 volts, you have a DC volt battery, you have a AC input over here, right? So in figure A, it's just a spot at the 0 position here, right? And 4.6.3b, you have a constant DC signal that is a 4 volt, which is again displays upwards because it has a magnitude. The electrons basically are hitting slightly upwards on the screen, but they are constant, right? They are not moving left and right, so you are not capturing the nature of the DC voltage, right? And then in 4.6.3c, you have the AC input over here. It is just basically alternating positive and negative, but appears to be a vertical line because again you don't have any motion in this direction here, right? So it's not able to capture the sine wave here, which is basically going to tell you with a certain amount of time, your electron will basically have a displacement in this direction, and it will basically display the screen to display this particular positive swing and the negative swing here, right? That is how basically time-based settings is important for your display wave of your waveforms here. Okay? If you don't have this, you will have the undesired output as shown over here, right? So now we have learned a oscilloscope. What is an oscilloscope, right? What are the control parameters of an oscilloscope, right? How can you display the waveforms on oscilloscope screen, right? Different type of waveforms, right? So this is just a summary. How can we measure the potential difference? So we have seen how do we connect this CRO in a block diagram way, but this is just a summary over here. Okay, how should you connect the input supply to an oscilloscope to measure it out, right? So an oscilloscope can be used to measure as a DC or AC voltmeter, right? You can also capture DC voltage here, as you saw over here, right? You saw DC voltage here, right? You also saw AC waveform here. So you can observe both of them on the oscilloscope screen. That is the beauty of this design, right? Um, yeah, so just saying you can just connecting by just connect the potential difference. Okay, just basically connect the battery or the AC source with your terminals of your oscilloscope. That will basically give you the They will give you the basically the waveform there, right? And the Y input basically shows the displacement of the trace in the vertical direction, right? So जितना आपका potential difference ज़्यादा होगा, let's say if you have a voltage of um, AC input, AC waveform, right, of let's say 15 volts, right? Let's say you have this waveform here, right? This is plus 15 and this is negative 15, right? So this would basically appear to be bigger as compared to a voltage waveform that is only of 2 volts, right? Let's say this is 2 volt here and negative 2 volt here, right? So this can be adjusted. Basically, it will be displayed on your oscilloscope depending upon your Y base setting, right? So जितना आपका मैग्नीट्यूड ज्यादा होगा वोल्टेज का उतनी वेवफॉर्म्स बड़ी बनेगी आपके पास on your oscilloscope screen, right? Okay. Then you also have this is just saying if the voltage settings, that is the Y key setting, is set to 1 volt per division, a vertical displacement of 1 volt division on the screen would be 1 volt DC input, right? So a vertical line 1 division long time based setting off would be produced by AC input 1 volt peak to trough. Okay. So it is just saying that if you have, let's say, two inputs, input A is this, it's basically this over here, 1 volt input over here, right? And then you have the second input, which is basically 1 volt here, right? So you will have 0.5 here and negative 0.5 here. This will basically be over. If you go from positive peak to negative peak, this is going to be completely 1 volt over here, right? So they're saying you can basically adjust this. So your settings of your oscilloscope is basically as follows. That is your Y gain is 1 volt per division, right? So how is it going to be displayed? This is going to be displayed as follows. So you have your oscilloscope screen. ठीक है ठीक है you have 6 boxes here. ठीक है 1 2 3 4 5 6 1 2 3 4 5 6. ठीक है. So what is the setting, by the way, of your Y gain? Your Y gain setting is 1 volt per division. ठीक है. And this is your center of your screen. ठीक है. मान ले center है. It's roughly scaled here. This is your time axis. It's in millisecond. And this is your voltage in volts here, right? So your setting is this. Y gain is 1 volt per division. That is, your every block basically shows, this shows basically 1 volt. Okay, this shows 2 volt here, this shows 3 volt here. Just imagine basically स्केलिंग योर एक्सिस, ठीक है, फॉर प्लॉटिंग ग्राफ। वैसे ही है। तो अगर आपके पास यू हैव बेसिकली अ डीसी इनपुट, ठीक है, which has the value of 1 volt. Let's say you have a CRO here, right? And you connect this basically with a DC battery, right? Which has the 1 volt magnitude only. So it would be displayed like this. It will be displayed like this. Okay. This is 1 volt point here, right? And similarly, if you duplicate this for your AC waveform, ठीक है, अब क्या है, what is the scenario now? You have the AC waveform input here, right? So now you have AC input waveform here, ठीक है. So that is again 1 volt here, ठीक है. If it is showing 1 volt here, so it's going to be displayed like this. It's going to be displayed like this. This is 1, this is -1 here, right? And it's going to be displayed as follows. Let me just make it correctly. Okay, this is going to be 0.5, this is half, this is -0.5 here, right? So this entire waveform will have from positive peak to negative peak a magnitude of 1 volt, right? So that's how the screen, the oscilloscope basically settles, auto-tunes itself to display different type of waveforms here. Obviously, you can change the Y gain settings to make it enlarge, right? And so on and so forth, right? So that's how it is basically going to display your outputs, right? I hope it makes sense. It's not so difficult, right? So now this in this scenario, you had basically this example over here, right? Now if you basically do what? Yes, में आपके पास time settings on थी, right? This was on, ठीक है? And the time based setting was on here, right? So now if you do what? Let me just mention it over here. The time based setting is the time base is on, right? The time base is on here, right? So now you do, if you do, let's say turn it off. हम देख चुके हैं पहले क्या होगा, ठीक है? Let's see अब क्या होगा if you turn it off. Let me duplicate this and let me bring it down, and let me duplicate this also and let me drag it down. Oh, okay, not so down, not so down. Okay, so now your time based setting is off. Okay, we have seen this now. I believe you can guess it now. क्या होगा? So your it's off, right? Now it's off basically. It's off. It's off. Okay. Now what will happen? Obviously, your screen will not move in left and right direction. You will have just a single dot, right? You will have just a single dot at the 1 volt point here, right? And similarly, over here, instead of having an entire sine waveform, you would have what? You would have just a line, right? Just a line from positive zero point 0.5 to negative zero point 0.5, right? So I guess you have seen this over here. It's just the summary. Okay. इसमें क्या होगा, ठीक है? This is what is written over here. So, so now when your time waveform setting is on, so you have the following scenario जो हम पढ़ चुके हैं, which is basically here. So I can take it above, ठीक है? तो यहाँ पे आपके पास it was off, ठीक है? So now your when your time based setting is on, it basically works in its normal state. That is going to this is going to display the waveforms, right? And let me just bring the example over here too, just to summarize, just to make it basically make consistent, ताकि आपको समझ आए when you're revising it out, right? So when your time based setting is on, so it's going to basically display the normal waveform, which are basically sending, which are getting sent into your input. And let me just summarize the results over here, which are summarized in the discussion. So when the time based setting is on, the oscilloscope acts as a graph plotter, right? It just plot x comma y, ठीक है? It basically plots the potential difference on the y-axis and the time variation in your x-axis over here, right? So it displays the figure 4.6.4 displays two types of basically AC waveforms here. You can see कि इसकी frequency हमारे पास low है, right? इसकी frequency हमारे पास ज़्यादा है, ठीक है? Because we can see the more number of cycles in the fixed amount of time, right? So it is displaying two signals which have different frequencies here, right? So in figure 4.6.4a, the time based settings is same as the input, ठीक है? And the complete waveform is obtained here, right? So for the trace in 4.6.4b, so it is half that of the input and two waves are formed here, right? It is just saying कि the time period, ठीक है? It is just displaying basically one cycle here, right? So one cycle का जो time period है, that is basically for only one cycle here, and you can simply find out the frequency of this cycle using 1/t, right? अब आपने क्या करा है, आपने जो टाइम पीरियड था फॉर द वेव फॉर्म, ठीक है, फॉर दिस न्यू वेव फॉर्म ऑन फिगर बी इज बेसिकली हाफ ऑफ द फिगर ए. दैट मीन्स कि यू आर हैविंग टू साइकिल्स नाउ, ठीक है, यू आर ऑब्टेनिंग डबल साइकिल्स इन अ फिक्स अमाउंट ऑफ टाइम. It also captures basically four divisions, four boxes to capture one plot in the same distance. That is a four divisions. Now you're seeing two cycles here. That means कि आपने इसका frequency ज़्यादा कर दी है, right? So this frequency of the high waveform is basically twice the frequency of the low one, right? That is the relation between these two here, right? Then you can basically see these two settings here. ठीक है, ये क्या हो रहा है? So you can just read this on your own. Read on your own. It is just a summary of what we had discussed now. ठीक है, ठीक है. So this is just what you can display over here on your different type of scenarios here. ठीक है. Just one last thing over here. Then we can basically move on towards the question answers. That is, okay, how do you measure the time period? How do you find out the frequency of the waveform? Right. So for that, let's see what is the settings right now. So my setting is basically time base is basically 10 millisecond per division, right? And we want to basically refer to figure 4.6.4p, right? So let's see how can we find frequency of a waveform, right? We have 4.6.4b, right? So let me copy this diagram and let's move on. वहाँ पे करते हैं solve. Let's solve it here. This is a very simple topic, but a difficult one, right? ज़्यादा बच्चे इसमें गलती करते हैं. You don't know how to just basically read the graph. ठीक है. So what is the setting right now for the setup? Our setting is as follows: that we have a time based setting of 10 millisecond per division. That is, one box shows a 10 millisecond difference. We want to find out the time period. We want to find out the frequency of the signal, right? So first of all, the first step should be finding one complete cycle. Okay, so I can see my one complete cycle is from basically here till here. Okay, this is my one complete cycle, right? This is my one cycle here. So now I need to find out how many boxes it takes to complete one cycle. Okay, so it takes is basically two divisions, or you can say two boxes, right? So I can apply now ratio method here. I can apply a ratio method here, right? So what does it tell me? It tells me what is my setting right now. My setting is that my one division, my one box basically captures a difference of 10 milliseconds, right? So if I have two divisions that is completing one cycle, so how much time it takes to complete one complete cycle? So cross multiply it out. So you get that your one complete cycle takes 20 milliseconds, right? And this is your time period of your wave here, right? So now you know what is the time period of your wave. That is 20 millisecond. So from this, you can find out what the frequency, right? And what is the relation of frequency with the time period? It is 1/t. Okay, so just put the time period value here, 20 milli. What is milli, by the way? Milli is 10 to the power minus 3. If you solve it out, your frequency is going to come out to be 50 hertz, right? So that's how you can use the diagrams, the Sierra plots to get your answer here.